Hello everybody, welcome to our video tutorials. In this video we will show you how to create a new connection to a LS6XT device, adding a Modbus data point to this connection, receiving and processing this Modbus data and include it into the min-SCADA visualization. Concrete, we want to receive the control bits 1 from the 5300 protocol. This Win16 value contains 16 control bits. We want to extract the fourth bit, which is the CBA closed flag, and use it as MCB feedback in the visualization. Before to continue, please verify that there is LS6XT device connected to the same network as the EasYview. Open the @Device Connect configuration tool and select Configure Product over Network. Select the station that represents the EasYview device and press OK. Open the new connection wizard by selecting the plus icon. Fill in a name for the new connection and press Next. Select the Modbus protocol and press Next. Fill in the IP address of the new LS6XT device and press Next. Select the Modbus slave address of the LS6XT device and press Next. Double-check the settings and press Save. Now a Modbus data point needs to be added to the new LS6XT connection. Before doing this, we recommend getting familiar with the Modbus syntax. Therefore, open the Help. Under Item Syntax, the Modbus item syntax can be found. If the Modbus syntax is known, select the symbol list icon to open the symbol list view. Select the LS6XT connection. Add a new symbol, data point, with the plus icon. A data point requires a name and a Modbus syntax. In this example, we want to receive the control bits 1 from the 5300 protocol. It is a Win16 value with the Modbus address 50072. For more information about the 5300 Modbus protocol, refer to the appendix in the LS6XT manual. Press OK and close the symbol list view. To verify that the communication works properly, open the logic table view and select the pen icon. Then select the new created data point and press OK. If everything was set up correctly, the status shows OK and online value shows any integer value. For this tutorial, the @Device Connect configuration tool is not needed anymore and can be closed. All changes are directly saved in the EasYview device. Open the @Device Builder and connect to the @Device server on the EasYview. Create a new folder for the LS6XT data. Go to Server, My Server, Objects and vSU. Right-click on the vSU folder, and select Add Node and then Folder. Fill in a name for the folder. Under Data Sources, right-click on the @Device Connect Modbus TCP and select Browse. Browse to Objects, Topics, LS6 and select the new created data point. Right-click and copy the control bits 1 node. Right-click on the new LS6XT folder. Choose Paste and Mirror in /output and node. Fill in a name or use the recommended name. It has now created a node that saves a Win16 value. The mirror input-output node represents the reference to the @Device Connect data point with the address 50072. Now create subnode which will save the CBA closed bit. Therefore, right-click on control bits 1, select Add Node, Data Variable and choose Boolean. Name this node CBA closed, for instance. Choose any name and press OK. As next, create a script that will mask an integer value to get a single bit. Right-click on control bits 1, select Add Script. Then open the details view of the CBA closed node by double-click on it. The node ID of the CBA closed node is needed in the script later. Now start editing the script by first double-click on the script code node. First, add an input parameter which will trigger the script. The parameter name is a free variable name. Type has to be node. Trigger needs to be checked to run the script every time the value changes. As value, select the control bits 1 node by browsing to it. Define a variable that references to the target node, which is the CBA closed node. The UA.findNode function will search for a node in the namespace and returns a node object back. To get the full reference of the CBA closed node, go to the Details tab and copy the node ID. Now mask the control bits 1 value and assign it to the CBA closed value. For the control bits 1 value, we have to use the input variable as defined in the input parameters section. The mask is 0, x, 8, because it is the 4th bit. At last point, assign the status. This is not required, but helpful in case of a communication issue, for example. Then the control bits 1 node and the CBA closed node will have the same status indication. Save the script. Every time the value of the control bits 1 node changes, the script is called and saves the masked value to the CBA closed node. At last point, use the new CBA closed node for the visualization. Therefore, open the MODI device view page and select the display object. In the attributes view, expand the parameters. At MCB, remove the relative reference by clicking on or open the object selector and browse to the CBA closed node. Select the node and press OK. Now the MCB breaker feedback in the visualization opens or closes depending on the CBA closed bit, which the LS6XT is sending via Modbus. Save the multi-device page. To fully integrate the LS6XT, repeat the steps of this tutorial for additional values, like mains voltage, frequency for instance, or duplicate some breakers objects, and create a H configuration with multiple LS6XT devices.